Kia ora and welcome to this quick overview of this flash animation by Greenbowe. So if you just Google Greenbowe and you look for redox, you should get something like this. So we use this to work out the reactions between metals and metal salts, so we can work out which ones are the more reactive ones and which ones are less reactive ones. So if you click on Start, you're given a number of different solutions. So if you click on a solution, you can see the magnesium ions, which are the ions of the metal, and the anions, which helps balance the charges, the nitrates. The nitrates do not take part in the reaction, they are the spectator ions. So if we look at different ones, these are copper nitrate. Again, we have the nitrate ions and the copper ions, and they're moving around all the time. So let's go to activity 1, and we can start off by putting a piece of magnesium into each solution: magnesium nitrate, zinc nitrate, copper nitrate, and silver nitrate. And you'll notice if we remove them that some of them have reacted and one hasn't. You wouldn't expect magnesium to react with its own salt of magnesium nitrate. But we can see that magnesium is reactive because it has reacted with all of them. If I did the same with copper, and I put copper in, and you will notice there's only a change in one, and that is the copper with the silver. So we know copper is more reactive than silver, but it is less reactive than zinc and magnesium. Now these observations are what we call the macroscopic level. So the three cornerstones of chemistry are the macroscopic, the microscopic, which is happening at the particle level, and the model. So we can have a look to see what happens at the model level. So if I take, for instance, my magnesium and I put it into my copper and I start it, okay, it says we're not going to have the spectator ions or the water molecules because they don't take part in the reaction. And if you have a good look, you'll see the copper picks up some electrons from the magnesium hands over electrons, and the magnesium now forms an ion and goes into solution. So we can see this step by step. So the electrons from the magnesium, so magnesium is a more reactive metal and it hands over its electrons to the copper 2+ ion. So we show it by a solid magnesium reacting with the copper ions to form a solid copper metal, and the magnesium goes into solution. The second equation, which is our model representation, is an ionic equation, and it clearly shows that our magnesium metal goes into solution. Aqueous stands for solution as an ion, and the copper ions, which were in solution for the aqueous, now form a solid. So let's have a look at it in detail. There you see magnesium is ready to give away its electrons, and magnesium is what we say oxidized because it is losing 2 electrons. 2 electrons have been given away. So we're breaking up this reaction into 2 halves, showing the first part magnesium giving away electrons. So you can see it's given away electrons there. And now what happens is copper, the ion, has gained those electrons, so it is now neutral, whereas magnesium has become positive. And so we show that our copper ions have gained electrons to form a copper metal. And so the magnesium ions now go into solution. So you can explore this animation. There are a number of different ones. So these different solutions. Have fun. Goodbye.